Okay, I'll help get you started on this one. Board 2 has some more detail, but it looks to me like we want to evaluate this integral, this definite integral, for the value little a equals 1, and we're finding using the greatest integer function of 10,000a. So whatever a turns out to be, we'll multiply by 10,000 and then find the greatest integer that's less than or equal to that. And that looks like what's happened over here. Here's the capital A definite integral evaluated for a equals 1. And I got this 1.465 multiplied by 10,000, got 14,605 point. And then here is the greatest integer function. Looks like that's the answer. Now, if you have to actually evaluate this definite integral, it requires about 5 substitutions at least. So it's a long, hard, difficult problem. I'll give you some ideas. We might start by letting u equals this x minus 1 under this inside radical. Then du equals dx. If we solve for x, we get x equals u plus 1. And we'll also make note here that we can change the limits of integration, so we don't have to back substitute at the end. So when x is 1, u is 0. When x is 2, u is 1, from right here. And now here's the u substitution. Replace the limits of integration. This x becomes u plus 1, and the square root of x minus 1 becomes the square root of u. And now we still have this radical, inside radical. Let's try s equals the square root of u, which is u to the 1/2. So the ds equals the derivative of u to the 1/2, which is 1 over 2 radical u. And that implies that du equals 2 u to the 1/2 ds. But this u to the 1/2, we've already seen right here, is s. So we've got 2s ds. And if we square both sides of this, we get u equals s squared. Limits of integration remain the same. So now I've got a definite integral that's in terms of s. I've got, so u is s squared. That's this u right here. The square root of u is s. That's what this is. And then I have this plus 1. And then I replace du with 2s ds. So there's our definite integral. Question is, what do we do from here? Are we making progress? Well, at least we got rid of one of the radicals, the inside one. Now we have to use some trigonometric substitution to try to get rid of this radical. And we might be able to complete the square here and make this a perfect square trinomial. So half of b, the number in front of s, is 1/2. Squared is 1/4. To keep it in balance, I have to subtract a 4th. So now I've got the 2 times the definite integral from 0 to 1 of s times the square root of s plus 1/2, the quantity squared, plus 3/4 ds. And this is where I'm going to stop the video and let you see if you can keep going. We have to use trigonometric substitution. So I might let w equal s plus 1/2. Let me make that a script s. Find dw and use trigonometric substitution, which is going to convert to something with tangents or secants or sines.
So I'm going to leave it there for now, and we're approaching 5 minutes, and see what you can come up with. Here you go.